Yes.
Okay. So we learned standard deviation, so that is taken care. Now let's look at the next part of the syllabus. So let me go from beginning. Let's look at it one by one. So the first chapter that I had was numbers and roundings that we have done. Let's go to the next one. This is operations and negatives. So this one also we have done. This is more to do with the BODMAS or PAMDAS, whatever you call it, right? The sequence of operations. Yeah.
Yes.
Then we go to the next chapter, which is more on the geometry. Geometry, where we learned different shapes and the properties. Did
Yeah.
we? We talked about different types of triangles, quadrilaterals. Did we?
Yes.
Okay. And do we remember all the properties of rhombus, kite, trapezium,
I
and
think
all that?
so.
Okay. Okay. And then we know what are the different types of angles and how that relates to the properties of triangles. Correct?
Yes.
Okay. Now, have we learned something on the congruence? I don't recall. Yeah.
No.
Okay. So let's learn the congruence theorems uh, for triangles. Okay.
Okay.
So what I will do is I will turn on my video for a little bit, and then I'll give you some lame examples. Okay. Now, you can see me.
Yes.
You can see this.
Yeah.
This is my hand. This is my other hand. Yeah.
Mhm.
You can see two hands right now. If I do this, how many do you see now? Only one
One. Yeah.
from this side and from this side.
Yes.
Imagine if my hands were not of the same size, how it would have looked like this,
Mm-hmm.
or if I would have flipped, it would have looked like this. Yeah.
Yeah.
Similarly, look at this phone and this AirPod. If I put this AirPod on the phone and I see it from this side, I can see two objects.
Yes.
If I flip it, how many I do I see? I only see the phone,
Yes. So one object.
only one object. So the phone is actually kind of overriding whatever we have with the AirPod. But in the case of AirPod, it is not able to do so. So there is difference in size, if I can say in simple terms. Yeah,
Yeah.
they're not exactly the same. If I had two phones, there's an iPhone 13, pretty old one. So if I have two iPhone 13, same specifications, if I would have put them right after another one, like the way I was playing with my hands,
Mm-hmm.
it would have completely overlaid it. Yeah.
Yeah.
Any which way, if you look at it, it would have looked one, right? Like the way you're seeing my hands. Yeah. Yeah. These are
Yeah.
practical examples. So this is what we mean by congruence. Okay.
Okay.
So when my one hand was able to completely overlay my second hand, you saw that you can see only one hand at a time.
Yeah.
Similarly, if I share my screen, let me open up a whiteboard and show it to you. So I will take few minutes to kind of explain what I'm trying to explain with respect to congruence, and then we should be able to relate that with our day-to-day thing, right? And then when we do math, we'll be able to kind of connect the dots always. Now, can you see my screen?
Yeah.
Can you see this whiteboard?
Yes.
Okay, this is one triangle. This is another triangle. Regardless of what the dimensions are, you can clearly see that these two are different in size. Yeah,
Yeah.
they're not looking the same. If you try moving this triangle to here and place it on the top of this one, this is how it will look like, right? Or if you move this guy here, try hiding it behind this one,
Hmm.
or try flipping it. You'll see only one triangle, but the smaller one is there in the background that you can see by flipping it. Yeah.
Yes.
So this is a classic case when we try relating these things and say this is what is congruent and this is what is not congruent. When we say two things are congruent, meaning the example of my hands that you saw, those are congruent, meaning they're exactly the same.
Yeah.
Thankfully, they are the same. Okay. I mean, if that was not the case, people would have said your body is deformed. Yeah.
Hmm.
So, but anyways, not going to the sensitive things. Some of us do have, like my one foot is slightly different from the other one, and that I believe that that's a case with many other people actually. Your shoes, even if they are exactly the same in size, but one foot will have some gap in the front, some will have not no gap, right? I mean, so anyway,
Yes.
so when you look at that, this is what is called congruent. When I say two things are congruent, what I'm saying in simple terms is they're exactly the same. If I say
Okay.
these two triangles are congruent, meaning I'm saying these two will completely overlay each other, meaning this side are same, this side are same, this side are same, and also the angles are same. So they have one matching value on the other side. So if this triangle has three sides and three angles, there's a corresponding side in this triangle which is matching with this one.
Okay.
Yeah. Same way, if I say this angle is also these two triangles are congruent, meaning they are both the triangles have matching pair of sides. So one side in this one will be equal to this one. Other side in this one will be equal to this one. Third side will be equal to this one. Okay.
Hmm.
Same way, there'll be corresponding matching angle between these two triangles. Okay.
Yes.
So forget about all mathematical concepts. As a normal human being or as a child, we will always we will think that okay, when two things are congruent, they're exactly the same. That's how we will think about it. Okay.
Okay.
Though congruent is a much heavier word, it sounds something fancy. And when we say same or similar, not similar, I'll say they're exactly the same. So same looks much more kiddish, simple word, but much more connected, right? So when you say congruent, you can always relate. Say, okay, that means they are same. They have
Yes.
properties, and when I say two shapes are same, I'm saying their properties are same. Meaning, if I'm looking at a quadrilateral, what do I mean by property? It has only two properties. These are one property is the sides, and other property are the angles. There's
Hmm.
only two properties we have. Yeah. And third property is the relationship among the sides and the angles, whatever, right? So the other property, that is what defines a quadrilateral or a triangle, right? If I'm talking about a triangle, what are the properties? Properties are sides and the angles. Yeah.
Yeah.
So when we say two shapes are congruent, we are saying their properties are matching. That will be our simple interpretation. Okay. Now, so far so good.
Yes.
Now, mathematicians have derived standard ways, right? I mean, whatever we say by looking at these two triangles, that is based on our eyes, based on how our mind reads it, based on how we interpret it. And we say, yeah, they look similar. Maybe they are congruent. But when it comes to mathematics, there's no space, no opportunity for any guess. So we have to give a proof. We have to be more accurate. We should be able to validate and confirm. So, mathematicians have said that when it comes to triangles, congruence for triangles, there are four theorems. Do you know what are those? Have you heard of them? Theorem for congruence of triangles. I'm sure you would have heard about it. Let me help you recall.
Okay.
One is called SSS. Second one is called ASA.
Ah, yes. Of course.
Third one is called SAS. And the fourth one is
Uh,
or edges. Yeah. So
okay.
these three theorems are for triangles, uh, meaning any triangle. This fourth one is only applicable for right angle triangle.
Okay.
Now, when
City back down there.
when you say theorems,
Yeah.
theorems are something that you should be able to prove. Okay, meaning
Yes.
among all the theorems, this is the only one that is given or told as a fact. What it means? That means when we say two triangles are congruent, and the theorem that we apply is it says if the three sides are same, if between the two triangles the three sides are same, meaning let's say this is side 1, this is side 2, and this is side 3. Okay, if this triangle and this triangle are congruent, that means there'll be one side which will be same as 1, there'll be one side which will be same as 2, and there'll be one side which will be same as 2, as 3. If two triangles have matching pair of sides, meaning one side in one triangle is matching with another triangle's one side,
Okay.
second side in first triangle matching with another side in the second triangle, and third one as well, then these two triangles are congruent, meaning each and every property will be matching. I'm taking a pause, just helping you digest what I said. So if you look at it in very very simple way, SSS meaning all sides matching. S stands for side, S stands for side, S stands for side. All sides matching. If two triangles have all sides matching, they are congruent.
Okay.
Yeah.
Yes.
So what it means is now if there are two triangles and they have sides matching, they are congruent. How you will interpret that is that if they are congruent, meaning one of the angle will match with this guy, one angle will match with this guy,
All
third
right.
angle will also match with this guy. Because if they are congruent, meaning they are exactly the same, so their angles have to match. So if you're dealing with any two triangles and they have matching sides, they are congruent, meaning every other property will also match. And that is what SSS theorem says. And this one we don't have to prove. Okay, we'll prove the other ones, but not this one because this is a proven one. Now I'll tell you why. I'll tell you why it is proven. Let's say you are been given a triangle. Let's do an exercise. Let's draw a triangle. You have a ruler and a pen with you. Can you
Mm.
get one?
And things I have my iPad with me.
Okay, you can use that, right? Okay, okay.
Yes.
I'll let you do the way you want. I'm saying draw a triangle with sides as 3, 8, and 10 centimeters. Okay,
Okay.
there are three sides. And spend 5 minutes and tell me if you can draw two different triangles. Two triangles which are looking different with these dimensions. Do you know how you can draw it, right?
Uh,
If
yeah.
you know three sides, you know how to draw a triangle, right? You can pick
Yes.
any side as a base and then make a circle with, let's say you picked 8 as this one. You pick this as a radius and draw a circle on this point,
Okay.
and then pick 10 as a radius, draw the circle on this point. So these will meet at two places. Okay, so this could be a one triangle, or you can join this way. This will be another triangle, and they'll be exact mirror image of each other. So Now I've given you the clue. Try drawing two triangles with this dimension and see if you can draw two triangles which are different by any means.
Okay.
See if you're able to. Try that. I mean, just for the sake of doing fun. Otherwise, no, I'll tell you, okay, this is a theorem. You don't have to prove. This is a proven fact. Just agree to what I'm saying. And that is not the way I teach. I'm asking you to challenge me to draw two triangles with this dimension. Okay. So try drawing two triangles and tell me if you're able to make two triangles which look different. And you have 5 minutes. Let's see if it is fun. Let me know if you had any luck in making the triangles different.
Okay.
Let me know once you're ready, okay?
Okay.
And see, this is not something that we are doing to be accurate or something. It's more of an exercise to build that practical, what do you call, awareness about things. Yeah. So we'll not spend too much time, but yeah, see if you can confirm once you are done making one triangle at least. And I'll be happier if you say that yes, I was lucky in enabled in making the two triangles different, because that'll give me another opportunity to learn something which I have not learned. Let's see. Okay. So without wasting much of your time, Riddhi, okay,
Yeah.
let me tell you, you will not be able to.
Yeah. They look both the same, honestly.
It will be the same.
Mm-hmm.
Because if you have one base, okay, and let's say three sides, A, B, C, the other length, okay, let's say A, B, and C are the length. You took length A and use radius B to draw a circle, use radius C to draw a circle. Let's say these two met at two places. If you join this is what your triangles are. This is one triangle, this is second triangle. And here, this radius and this radius will be the same, right? This is a circle. Radius is always the same. So
Yes.
basically, this length and this length will be the same because they're radius. Same way, this and this are the same. And you can see that this is exactly symmetric. By no means, there's a third triangle that you can draw. You'll not be able to draw a triangle like this with this dimension. Okay. There'll be
Mm-hmm.
only two triangles that you'll be able to draw. Okay. So that is why your triangles, this thing is fixed. Now you can do that. You can do other things. Say if I gave you ABC, I'll just clear it. Say it's your 3, 8, and 10. This was my dimension, let's say. I can pick 3 as a base and then make a 8 centimeter circle and 10 centimeter circle. It went like this. I
Yeah.
can pick 10 as a base and 3 centimeter circle, 8 centimeter circle. But if you look at this triangle and this triangle, it is just like rotated. There's nothing has changed. The length of the sides are not different. The angles will not be different. It is just like, my phone is standing right now and it is lying down right now. Something of that sort. Yeah. But
Mm,
the the dimensions of my phone is not changing. Okay.
yeah.
So it's just that either it's standing on this base or standing on this base or standing on this base. But eventually you will see the dimensions or the properties have not changed. They're exactly the same. So that's
Yes.
why you can be 100% sure that if there are two triangles or any if you have known sides, the only type of triangle that you can draw will be this, and then they'll be symmetric, they'll be congruent, they'll be exactly the same, they'll have all matching properties. Okay, so SSS is the theorem that is given to us because that is a practically proven thing that you cannot change. You cannot have two triangles with matching sides but different properties. Okay, is that okay so far?
Yes.
Okay, now let's look at SAS. What this theorem says? This theorem says that two triangles will be congruent if the two sides are matching, meaning this is 1 and this is 2. So this will be 1 and 2, and the angle between them are matching. Okay, meaning if you
Yes.
can find out two triangles who have matching sides and the angle between the sides also matching, then these two triangles will be congruent. And we will try proving this theorem. But before I try doing it, I want you to digest this first. Did you uh, did you follow me completely when I said SAS? What does it mean?
Yeah.
Okay. All right. So, and again, what I'm trying to say here is always you will always look at two sides and the angle between them. You will not see these two sides and this angle. The angle has to be the angle inside that. Okay, that's fine.
Yes.
Yeah. Okay. Now, so let's look at how do we prove it. Okay. So let's make it a more formal thing. I have, let's say, A, B, C. I have other triangle D, E, F. Okay. What the
Yeah.
theorem says is, let's say the AB is equal to DE. This is what is given to us. Okay.
Okay.
And second one is, let's say BC equal to EF. Okay. And the angle ABC is equal to angle DEF. Okay. If this is the case, then these two triangles are congruent. Okay.
Mm-hmm.
Okay. Now, how do we prove this? Yeah. So
Yeah.
let's look at the approach for doing it. Okay. Now, if we can prove, okay, let's you know Hindi, right?
Yeah.
Okay. So Hindi may we say ulta, in a meaning thinking in the reverse direction. When,
Mm.
let's say, if I can say I can do this, or you can see I cannot skip doing this. Or if you say no two times, that means yes, right?
Yeah.
I did not say no, meaning I said yes. Yeah.
Mm-hmm.
Now, so anyways, that was that was a distraction to what I was trying to say. So now let's say the other two triangles. So we'll use that word ulta that I used. That is what we'll use for proving this. Okay. Let's say this is my triangle ABC. Okay. This is my triangle DEF, and we know that AB equal to uh, DE uh, is sorry BC equal to EF, and angle ABC. This is the angle between the two lines is equal
Yeah.
to angle DEF.
Okay.
Okay. Now, so one theorem that we know that if I see that there are three sides which are matching, then they are congruent. But here in this case, we only know two sides are matching. We don't know about the third side. Correct?
Yeah.
So we want to find out. So here, what we'll do is let's clean it a little bit. So I have written this just for sake of clarity, but you know that okay, we are talking about which all sides are matching, which all angle is matching.
Mm-hmm.
So this side is matching, this side and this side are matching, and the angle between them are matching. Yeah. Now, if I can prove this side and this side are same, if I can do so, okay,
Yeah.
then these two triangles will be congruent because we know SSS is a proven thing that we have seen, right?
Yeah.
So if I can prove that the third side is also matching, then I can prove this, right? That if the two sides are matching, then then this will be congruent. Two sides and the angle matching, then it will be congruent, right? So our objective is to match, say that these sides are also matching. Yeah.
Yeah.
Let's assume that they are not same, meaning we are assuming that AC is not equal to DF. Okay,
Okay.
fine. And we will say that AC is not equal to DF. But what happens is if I make it little bigger, this line, if I extend this line, and let's say this is K, okay,
Yeah.
I will say I'm saying that AC and DF are not matching, but if I extend this line, then KC is equal to DF.
Okay.
Yeah. So now, okay, so you are getting me right. I have
Yes.
we have two triangles. We know two sides are matching, and the angle between them are also matching. What we are trying to prove is that the third side also is matching, and that is my only way to prove that these two triangles are congruent, right? We are
Yes.
trying to prove that, but we are doing it in the reverse way, the ultra way. Okay,
Huh.
we are we are saying that okay, they are not matching. Let's assume that they are not matching, meaning AC and DF are not matching. They are not of same length. Okay,
Yeah.
and to make it same, maybe we thought that okay, AC is smaller than DF. That's how they are not same. Yeah.
Yeah.
So I extended this line. That line AB I extended and took the length DF, D to F, this length, okay, and then made a circle. And wherever it cut this line, I said, okay, that is K. Now, after doing that magic, we are saying that KC is equal to DF. Now
Yeah.
let's look at triangle KBC and triangle DEF. Okay, are you with me so far?
Yes.
Okay. Now what do you see here? This, we are saying that this side, mm, let me phrase it correctly for you. We are saying that AC is not equal to DF, okay?
Okay.
And so we extended the line AB where it meets at K, where KC is equal to DF. So
Yeah.
what's happening is, hmm, okay, okay, yeah, got it. So now, okay, let me. I'm, yeah, I know what is the thing. I'm just trying to find out a way to explain that in a simpler way.
Okay.
Um, hmm, okay. So, okay. All right. Yeah. Okay. Got it. Now, look at another thing. Okay. Let's say you have one side and other side, and then you have angle between them. Okay.
Okay.
Two side length. Okay. Same angle. Okay.
Yeah.
This was my old triangle ABC. Okay. This is DEF. Okay. What we said was that AC and DF are not matching. These two sides are same length. This angle is also same. Okay.
Yeah.
This side and this side are same length. This angle, the same angle. We are saying that this is not equal to this, but this is equal to this. And
Okay.
that is not technically possible because let's say if you have two sides, see this side, this distance, if I had, now you go back to this angle. Now you look at this angle and this angle. Come on. Okay. So this this side has to be the same as this side. That is what the case will be because your it's like you have what you call two sticks. Okay, you are
Yeah.
putting the sticks at a certain inclination. Okay, this stick and this stick,
Mm-hmm.
certain inclination, and here to here, this distance and this distance will be the same because the angle between them is the same, and here to here the distance is same.
Yeah.
So if you, let's say if you draw uh, one second, there's another way of doing it. I'm just trying not to confuse you. Okay, when we had drawn this one, I'm saying, hmm. So I'm saying that this here to here AB is equal to DE and BC is equal to EF. I'm saying AC is not equal to DF. Rather, C to K is equal to DF. Okay.
Okay.
But tell me, is this technically possible? And I'm just thinking how you can prove it in a easier way. One second. I'm just. Um, Okay. Mm, in okay. This um there's one easy way. Just give me 2 seconds. I'm referring to something that would have been a easier option. Okay, this is mm, okay. Yeah, simple. Let's forget about everything. Now
Mhm.
let's look at a simpler situation. Okay, I know you guys don't have to prove these theorems. You have to just know it. But when we were studying it, we had to actually prove it also. That's why I'm trying to recall how I can kind of get this deep in your mind so that no, it doesn't go away anywhere. So okay, so this and this are same. This and this are same. This angle and this angle are matching. Now what we do is um delete this one and delete this one. Here you can see that. See, this is a what do you call? Let's say you have drawn these two sides. Okay, these two sides. Sorry, these two angles you have drawn. Okay, with the given side, this side matching with this one, this side matching with this one. Okay,
Yeah.
and this is the angle that you have kept. You did not keep this angle. You did not keep this angle. You just match the angles. Okay. Now now what we are going to do is from here to here. There's one practical way of doing it. You can just add, look at length from here to here, look at length from here to here. You will find that matching. But second option is, let's say that this is not equal to this. Okay, we are saying that this is not equal to this. This is not equal to this. Rather, this is equal to this. Okay, meaning A, B, C, D, E, F. We are saying that CK is equal to DF. Now, this is, even if we assume that CK is equal to DF, that will not be the case because technically this is not possible. If you have two lines at a certain angle, the distance between them will be fixed. Okay. So for the sake of argument, we assume that okay, let's say this is not equal to this. If these sides are matching and it is equal to this, then that kind of defeats the whole thing. Okay. So you pick up any angle. Let's say okay, let's say 30 degree. Okay,
Okay.
this is 5 centimeter and this is 10 centimeter. Okay, here to here,
Okay.
what is the distance from here to here? That is a function of what is the inclination between these two lines, meaning what is the angle between them. Okay, if the angle is bigger, let's say 110 degree. Okay, then this distance is a function of this angle. Okay, if the angle is 10 degree only, then look at the third side. Okay, this is 10 degrees. Okay, yeah, I think I got a better way to explain this. Okay, now
Okay.
now we know that okay, if I have an angle this, okay, this is
Yeah.
20 degree, this is 5 centimeter, this is 6 centimeter, let's say. Okay, these are two sides, 5 centimeter, 6 centimeter, and the angle is 20 degrees. Yeah.
Yeah.
Now let's say the same side 5 centimeter, and then 6 centimeter, but the angle is 45 degrees. Okay.
Okay.
Next 5 centimeter, 6 centimeter. Okay. This is not bigger. This same as the other guy. Okay.
Okay.
And but the angle is, let's say, 95 degrees. Okay.
Yeah.
Now same 5 centimeter, 6 centimeter, and the angle is 75 degrees. Okay. 5, 6, 5 centimeter, 6 centimeter, 5 centimeter. Angle is 140 degree. Okay. Now, now what do we see here? This distance is smaller, yeah,
Yeah.
compared to this distance, because they are getting farther, right? You can see that visually also. Yeah.
Yeah.
When the degree angle is increasing to 75, it is even bigger. This side, length of this side, actually. I'm talking about the length of this side, okay?
Yeah.
The length is becoming bigger. Yeah.
Mm-hmm.
See, the length is becoming even bigger. Yeah.
Yeah.
So what it means is the length of this side is a function of two things: this side and this side's length, and the angle between them. If the length of the side remains the same and the angle keeps on changing, the length of this side keeps on changing. Yeah.
Okay.
Yeah.
Yeah.
Meaning you have two sides with fixed length, and if you join the edges of the open ends, right, to make it a triangle, bigger the angle, bigger the third side. Yeah.
Okay.
Okay. That you can see, correct?
Yes.
So now come back to this one. Here we are saying that these two angles are same. This side and this side are same. If the angles are same, the sides making that angle are same, by no means this can be different.
Okay.
Making sense?
Yes.
So again, I know I purposefully confused you a lot. I would not say purposefully, but I was trying to find out ways to make it simpler for you. So I gave you different examples, but simple thing. If you have to prove the theorem SAS, okay,
Yeah.
what it means is this is theorem for congruence, which says there are two triangles with two sides matching, or two sides matching, and the angle between them also matching. Then these two triangles are congruent. And what we are trying to do for proving it is, if we find out that the third side is also same, then we can assume that these two triangles are congruent. We can prove that these two are congruent. Okay, because SSS is something that we practically did, and we know that okay, this has to match. Okay.
Yeah.
Now what we did was we related that with the angle theory. That if I have two sides of fixed length and a given angle, my this side, third side, is a function of how big or small the angle is. If the angle is smaller, my side is smaller. If my angle is bigger between the two sides, my
Mm-hmm.
side gets bigger. Here in this case, the two sides are matching. These two sides are matching length. And this angle is also matching. So since this side is a function of this angle, right? And since these angles are matching, so my sides have to match. So that means
Mm-hmm.
if these two sides are same and the angles between them is same, this side cannot be different. For the sake of argument, we said that okay, it is not same and it is meeting somewhere here, okay, and then this is same. But then that all again contradicts our theory that okay, if two sides are same length, then and the angle is same, this side will be fixed. But We are saying that no, that is not the case. My two, this side and this side are not matching with this side, but this is matching, which again contradicts, right? So we know that if the two sides and the angle between them is same, then this distance will be the same. We were saying no, that is not the case. This one is same. So we are actually contradicting this theorem with the angle. That okay, if my two sides are of same length, then this has to be the same. We are saying no, this side is same, but these two sides are not same, and the angle, even if the angle is same, that is contradicting, right?
Okay.
Um, I don't get confident till I'm actually making it simpler. So let's look at these two triangles. Okay, so this side and this sides are matching. Yeah.
Yeah.
My angle theorem says that if my sides length are fixed, but the angle changes between them, angle is different, then this side's length will be different. This will be more. If the angle between them is smaller, then this side is smaller. Yeah,
Yeah.
that we can see. So that is one theorem. And we said, okay, fine. Let's assume that this side and this side are not matching. Even if this and this matching, this and this are matching, and this and this are matching. Then also we are saying these two are not matching. When it is matching is here. Meaning when I make this side bigger, then it is matching. And that is where we see that is conflicting with this theorem of this the angle thing, right? When you have two sides with a given angle matching, then this side is a function of that this angle. But here we are saying even the angle are same, this is not matching. That is why it contradicts. And so you can choose the simpler option. You can choose the simpler option always. Okay, don't go for this and then extending this and then understanding it that way. You will say, okay, fine. If I have two sides and the angle between them, my third side is always a function of this angle if the sides are same. Since the angles are also matching, this side has to match. This distance will not be different. Yeah,
Yeah.
confusing, kind of.
Yeah.
Okay, forget everything.
Okay.
Okay, this is 5 centimeters, 6 centimeters. Okay,
Okay.
5 centimeters, 6 centimeters. Okay,
Yeah.
I'm just giving two examples. Now, from here to here and here to here, what do you see? Let's say this is ABC and this is DEF. In these two triangles, what do you see? This side AB and DE is same. Yeah.
Yeah.
BC and EF are same.
Hmm.
What is DF? DF and AC are they same? Are they looking same? Visually.
Mhm.
No, assume that I have not taught you anything so far. Now tell me visually by just looking at the picture, does AC and DF look the same?
No.
They don't, right? Why? Because the space between these two lines, space between these two lines is more or less, right?
Yeah.
Or in mathematical terms, the angle between the two lines is more here, less here. Yeah.
Yeah.
So when the angle was more, this was bigger. When the angle was small, this length was smaller. Yeah.
Yeah.
So the and open ends of the lines or the length, this length depends on how small or big the angle is, right?
Yeah.
Imagine a third situation where you have these two sides same.
Mm-hmm.
same, and the sorry, and the angles also same. Will this be same? So again, I'm just relating it back to this thing. When the angle was more, side was more. Angle was less, this side was less.
Yeah.
When the angle is same, size will be the same.
Yeah.
Yeah. So for two sides of two angles with matching sides and the angle between them being same, the third this side which is connecting the open ends will be of same length because it's a function of the angle between them. Okay. Okay. I
Yes.
was just trying to prove myself wrong, saying, okay, no, this is not a function of this one, but this side is same as this one. But that is not correct. That can never be the case because we know that this side is a function of how big the angle is, or big the angle is. So that contradicts the basic concept. You can play with this. Okay, you can literally play with this. You know pick up any two sides, let's say 6 centimeter and 8 centimeter,
Yeah.
and make angle with these two sides. Okay,
Okay.
one with 30 degree, one with 60 degree, one with 140 degree, whatever, and then measure the length, this length. Okay, because you can always see it conceptually that the third side of a triangle is always a function of the length of the two sides and the angle between them. So when I used smaller angle, I saw the third side was smaller. When I used a bigger angle, I saw the side length of the third side increasing, so on and so forth. So that's
Yeah.
why if my two sides and the angle between them are matching, my third side will be matching as well. That's what we saw here. Yeah.
Yeah.
Confusing, loaded. Yeah.
Yeah.
Kind of. So just play with this little bit. Okay. So
Okay.
don't have to trust me. Just pick two sides with some length. Just keep that as a homework for you. Okay. 5 and 6 centimeter or 6 and 8 centimeter, whatever you want to pick. And try drawing angles 30 degree, 40 degree, 70 degree. And again, you don't have to draw them. You can use what you call that semicircle that you have, right? You
Yeah.
mark and join these lines. Okay. And then and then or what you can do is you have something like this, like a semicircle like this, right? Where you have 10 degrees, 20 degrees, 30 degrees marked, right?
Yeah.
So what I'm asking you is, let's say you take 6 and 8 centimeter sides and you have to draw with 20 degrees, 40 degrees and whatnot. So first, let's say you put 6 centimeter length, you make a line segment of this length, and then let's say 20 degree. So you'll put the semicircle here and see where is 20 degree, and you mark that point and draw a line like this, and then take 8 centimeter radius this thing and cut it here. So this becomes your, oops, what happened? Where did it go? Hmm, hmm. And then take 8 centimeter radius this thing and make a circle. See where it cuts this line. Join this point with this point. Measure this length. Another thing, let's say 6 and 8, 40 degrees. So same thing, you put 6 centimeter, then put that semicircle here. See where match this point. 40 degrees where it cuts. Draw this one. Make a big line, and then take that 8 centimeter thing and cut it wherever it cuts. Join this. So measure this length, and keep playing with some more angles and measure the length. And again, do one more with 20 degrees and then measure that length also, and compare the length for this angle and this angle, and see if they are same or not. That will
Okay.
give you the clue that okay, if I have two sides given and an angle is given, my this side is a function of the angle. If my angles are same, my this sides are same. If the angle is bigger, this side gets bigger. If it's further big, this is further big. Yeah. So when you
Yeah.
play with that, then you'll relate. And when it comes to doing that in exam, you can always say that I if I have these two triangles with the matching angle, this distance is a function of the angle between them since my sides are same.
Yeah.
Since the angles are same, the length of this side will be the same, and hence the third side is same. So we can say that if come on, if there are two triangles with two sides matching and the angle also matching, this side will be the same because this side's length is a function of this angle. Okay.
Okay.
So this since these two sides are so this side is also same, that means both the triangles have the three sides matching, so this is congruent. Now since these two triangles are congruent, everything else will match also. You'll say this angle also matching, this angle also matching. You can prove that. Okay.
Okay.
So the way the questions come in the exam for you, let's say somebody says this, okay, this is a triangle, 4, 5, 8 centimeter, 4, 5, 8 centimeter, okay, and this angle is 60 degree, this angle is 60 degree, okay,
Yeah.
and oh no, not this one. I made a mistake here. Okay, no, so I will remove this guy. Okay, so let's do this sum. 4, 5, and 8, and this is 4 centimeter, 5 centimeter. This is 60 degree, and this is 30 degree. Okay. Now find out the value of this angle, this angle, this angle. So I will call it 1, 2, 3. Okay, and this side. So when you have a question like this, right, that this is a triangle with 4, 5, and 8, and one angle is 60 degree, other angle is 30 degree. Okay.
Yeah.
Find out the third angle with the number 3 that you see here. I'm circling the ones where we have a question. Okay.
Okay.
Find out angle 3, find out angle 1, find out angle 2, and find out this angle as this side. Okay.
Yeah.
How will you find that? First of all, you will see this one. If you look at this first one, you have two angles given. You have to find out the third angle. Just give me 1 second. Just 1 second.
Mhm.
Okay. चलो खाना खाना मुझे बताना लॉक करना मत भूलना sorry beta. Okay, so in this triangle, you know that all the sum of all the angles will be 180 degree, right? So you have two angles given already, 60 plus 30. What will be the remaining angle? 90. Sum of all the angles is 180 degree, correct?
Yes.
And then you disposition the contact as agent BC, which is 1 and 2.
Yes.
And that's where I
Yeah. So sum of all the angles will be 180 degree. Two angles are given as 30 and 60. That means the third will be 180 minus sum of these two. So this angle is found 90 degree, correct? Are you with me so far?
Yes.
Now, so one angle you got. So let's say you got basic property of the triangle tells you that this is 90 degree. So you say, okay, fine, this is 90 degree.
Yeah.
Always go step by step. Now, between this triangle and this triangle, what do you see? One side and this is second side, 4 and 5. 4 and 5 are matching. Okay.
Yeah.
4 and 5 are matching. 4 and 5 are matching. Same length, right? And look at the angle between them also. This is 40 degree. Sorry, 60 degree. Between 4 and 5, this is 60 degree. So this is a case where you have two sides and the angle between them matching. Right?
Yeah.
This is a situation where you have two sides and the angle between them matching. That means these two triangles are actually congruent with this theorem.
Okay.
Right?
Yes.
Now, since these two are congruent, that means other sides and angles will also match. Now, look at this one 4 and 5, and third side is 8. We have here 4 and 5. Third side, we don't know. Third side has to be 8. No question about it. Yeah.
Yeah.
So, you got third side as 8.
Okay.
So, you found this one now. Now, see, look at this one. A bit of care is needed only. See, between um, we got the third side is 8. Now look at 4 and 8. What is the angle between them? 4 and 8 in the first triangle, this one. What is the angle
30
between 4
degrees.
and 30 degrees? Look at 4 and 8 here. What the angle between them will be also same.
Hmm.
So that will be 30 degrees. Yeah.
Okay.
And between this one, if you see, this is the angle between 5 and 8. What is the angle between 5 and 8? 90 degrees.
degrees.
So this will also be 90 degree.
Mm-hmm.
Or you could always look at, okay, two angles you have already got 60 and 30, so third will be 90.
Yeah.
Yeah. So this is just see this is not a complicated one. Only thing it says requires us is to look at relate it with the concepts. Okay. So
Yeah.
let's say since we have looked at SSS and SAS, yeah, these two theorems, let's do few sums. I want to give you 10 minutes to do some sum, and we'll see if whatever we have gone through, was it easy to understand? And then if you get stuck somewhere, that's an opportunity for me. Okay.
Okay.
So let's say there are two triangles. Okay. Do you know Pythagorean theorem?
Yes.
Okay. So then I'll give you only one sum.
Okay.
So there are two triangles, A, B, C, D, E, F. Okay. This is, I'm saying 90 degree. Okay. This one I'm saying 3, 12. Okay.
Mm-hmm.
I'm saying this is 90 degree. And I'm saying this one is um, okay.
Yeah.
So I'm just thinking. Um, let's say this is 50 degree and this is 40 degree. Okay.
Mm-hmm.
Yeah. I kind of disclosed the answer to you, but still, there are two triangles. Okay. I want you to find out the length of the other sides, such as BC, DE, and BC, DE, and all the remaining angles, meaning angle ABC, angle AC, yeah, yeah, B, and angle E, D, F. Okay. So this is one triangle ABC. I'm just reading it for you so that no you can relate it if you're not able to read my this thing. ABC is a triangle where one side AB is 5 centimeter and AC is 12 centimeter, and the angle BAC is 90 degree. Triangle DEF has the one angle DEF as 50 degree and angle DFE as 40 degree. And the two sides as DF equal to 12 and EF equal to 13. So what we need to find out is side BC, length of side BC, length of side DE, and the value of the remaining three angles. And the only clue that you have here is there are two clues here. Okay, one is you have to use the theorem of congruence, whatever we have learned so far, and you have to use Pythagorean theorem.
Okay.
And I was not supposed to tell you about the Pythagorean theorem, but since we have, I was trying to recall if I have explained Pythagorean theorem to you before or not, but we'll use that. Okay. Try doing this. I'll be on mute for next 5 minutes. I want you to try this,
Okay.
and I'll again see where you are, and just try it to see if I have taught it correctly or not. It's not about you know it correctly or not. Okay.
Okay.
If you are able to solve it, I will take the credit. If you are not able to solve it, I will get the blame. Yeah.
Okay.
Okay. So let's be on mute for 5 minutes and let me know once you are able to finish it.
Okay.
Yep.
Sorry, can I just see the question again?
So let me know, Ridhya, if you're able to progress. Are you able to progress or you're facing roadblocks?
Um,
Hmm?
can you repeat the question actually, please?
Okay. So there are two triangles ABC where you see this side AB as 5 centimeter and AC as 12 centimeter. And the angle between them is 90 degree. Okay.
Yeah.
Second triangle is DEF where the angle, this one is 50 degree
Mm-hmm.
and this angle is 40 degree.
Okay.
and the side is 12 centimeter, and the third side is 13 centimeters. So we want to find out what is the length of this side, what is the length of this side, and the three angles, this one, and this one. Okay.
Okay.
So do you want to give it a try?
Yeah.
Yeah.
Okay, I think I got it.
You got it?
Yeah.
Okay, wonderful. So let's look at it. Okay, tell me how much is it is. How much are the values?
Oh, BC should be 13.
BC should be 13. Okay. How about DE?
DE should be 5.
Okay.
ABC will be 50 degrees.
Okay. Uh-huh.
ACB is 40 degrees and EDF is 90 degrees.
Wonderful. Okay.
Yes.
Wonderful. Yeah. So here, what did we do? We applied three things that we knew, right? One is sum of all the angles is 180 degree for a triangle, right?
Yeah.
That is how you found this as 90 degree.
Yes.
As soon as you found 90 degree, what did you do? You applied
The congruence.
SAS. Congress term for congruence is SAS. Yep.
SAS.
So once you got SAS, then you proved these two triangles are congruent. That is how you found this angle and this angle matching with this one, relating to the sides. Correct?
Yes.
Okay. So that gives me confidence that yes, probably whatever we learned it right. Yep.
Mhm.
So there are two more theorems. One is called ASA and other one is called RHS. Okay. ASA means, see, when we looked at SAS, we looked at two sides and the angle between them. When we look at ASA, we look at two angles and the side between them. Okay.
Mhm.
So we'll try proving that in the next class. Okay. We'll not worry about that in this one, ASA and RHS in this class. Okay. We want to go slow. I'll give you some more homework on this one, so that you can give you some few problems that you would want to solve with SSS and SAS, and then we'll come to these two theorems. Yep.
Mhm.
So what I would want you to do is I'll give you a few assignments, maybe 5-6 sums. That's all. Okay, not more than that.
Mhm.
I would want you to solve them, and when you do this assignment, you can show the assignment to your parents. Say that the other assignment that I had got, and this is how I'm solving it. And this is a common approach I follow for all my kids who are doing the classes remote. Okay.
Yeah.
Because since I'm not able to check the assignment for them, there has to be some way to make sure that kids are able to learn things. And when they explain to their parents also get confident that yes, my child has learned something and is able to explain. And also it helps in a way that when you explain something to somebody, that is when you actually get to realize how well you have understood it. Okay.
Yeah.
And let's say if there was some gap with respect to understanding, or if you're not able to articulate it, right, or not able to explain it, that is when you will come back to me, say okay, fine, I was able to solve it, but when I was trying to explain it, I was missing something. That
Yeah.
becomes an opportunity for me to kind of explain it a little bit better. Yep.
Mm-hmm.
Yep. So that's the approach we'll follow here. Correct.
Yes.
So so far we were not doing much of assignment. We would want to get into the habit of doing some assignments also, so that way you get some confidence. I also get to be a little more confident that yes, I'm able to explain something, and then you're able to actually practice them, right?
Mm-hmm.
And you're able to explain that, it makes it much better. Yeah. So this is on the on the theorem that we learned. We will actually these theorems for congruence will also help us find out how the formula for area of triangle is derived. Okay, I'm not telling you right now, but we'll talk about it. Okay.
Yeah.
So we when we talk about the area of a triangle, quadrilateral, rectangle, square, whatnot, right? These areas have not come from sky. These are actually derived. Somebody actually found that out, and it becomes very easy for us to keep it with us as a knowledge for long if we understand how that is done. If you know the how part, right, that becomes much easier. That becomes a concept that will last with us much longer, right? Like this theorem for congruence, I had studied when I was probably in ninth or 10th grade, right, like you,
Yeah.
and I never got a chance to practice them. Now when I'm teaching you, I just tried recalling it, and then I tried relating with this concept that okay, if I have two lines of a given length, line segments of a given length, and the angle like this versus this, same line but different angle, the distance between them increases or reduces depending on how big the angle is, how big the angles are, and how far apart they are getting from each other with the angle. Yeah, right.
Yeah.
So that is how we relate things. So that's what we'll do. Now I'm just thinking what else we can learn quickly in next 7 8 minutes that we have. So let's look at, okay, so I'll give you homework on Pythagorean theorem as well as the 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 two theorem for congruence that we have learned. Okay,
Mm-hmm.
let's do something called composite shapes. It'll not take more than 5 minutes for us to learn. Okay, let's say
Okay.
you know how to find the area of a triangle, you know how to find the area of a rectangle, you know how to find the area of a square. Yeah.
Yeah.
Now, if somebody says find out the area of, let's say, let's assume that you know the area of a trapezium also. Do you know what is the formula for area of trapezium?
Yes.
Okay. So you know that. Now somebody says find out the area of this one and gives you the dimensions for all the sides.
Mm-hmm.
How will you find the area of this guy?
You would divide it into simple shape.
Exactly. Just play with the corners. Yeah.
Yes.
We have is now. We don't know whether this line and this line are parallel or not. So we'll say, okay, fine. Let's break it down into, let's join the corners. and make it simpler shapes,
Mhm.
and then find out the area for those guys. Yeah.
Yeah.
That's the way to deal with the composite shapes. By no means you would be able to find out the formula for area for the millions of shapes that we can come across. It's always, we know the basic shapes like triangles, rectangles, squares, trapeziums, um, let's say even rhombus. Those things we'll find out, and then that those areas will know, and then we'll break our complex shapes into those smaller shapes, simpler shapes, and find out the area of them all. Okay.
Mhm.
Add them together, because area is the space taken by this one. So this space plus this space plus this space plus this space, that gives me the total area of this composite shape. Yeah. All right.
Yes.
This is where we will stop our class for today. Any questions?
No.
No. um, how was the experience today? I know, see, when we start something, right, what happens is